Okay, so we said polynomial function is a generalization for integer. Okay, and so integer over integer is a fraction. So the generalization for fraction is a rational function. So this is a rational function is just like that, like p x polynomial over polynomial, right? Okay, so for a fraction, we can simplify if we can cancel something, right? Like 12 over 18, we can simplify or cancel 6, simplify to this. So for rational function or rational expression, we sometimes we also can cancel something, just like that, like this one. So we can simplify. So to simplify means we wanted to cancel something. So in order to cancel something, we want to fact the numerator part and the denominator part, right? So for this x squared minus 2 4x, so we want to fact them. So x squared minus 4x minus 12. We can fact this as like, let's say, so 1, 1, 12. We can change fact it as 2 times 6. Okay, to make a negative 4, so we can put a negative here, positive here, right? So x squared minus 4x minus 12 can be factored as x plus 2 and x minus 6. So the denominator x squared minus 4, we know this one can be factored as x minus 2, x plus 2. Okay, so we find we can cancel x plus 2, so we get this as this. So this is just simplify cancel something by factoring. Okay, so just like fraction operation, we can fraction multiply fraction, fraction divided by fraction. We can do those things. So here also like this. So this one we can multiply this fraction or this rational function, multiply that rational function. But the question is, before we multiply them together, so can we simplify? So at the first, we need to check whether we can simplify or not. So this means we need a fact. We just try factoring first. Okay, 4x squared minus 4x, we can take 4x outside. So this is x minus 1, right? So x squared plus 2x minus 3, I think we can factor this as x minus 1 and x plus 3. Okay, so here, so 4x. So x squared plus x minus 6. So x squared plus x minus 6. We can factor this as 1, 1, 2, 3. So here the positive, negative, right? Okay, so this we can factor this as x minus 2, x plus 3. Okay, so we found we can cancel many things, right? So 4x cancelled. X minus 1 cancelled. X plus 3 cancelled. So we find this one, multiplication, the result is this. So such a problem, we also can regard this just a simplification, right? Simplify. If we can cancel some things, cancel. Okay, So here, this is a division, like fraction divided by fraction. So we say divided by a fraction can be changing as multiply. Multiply is reciprocal, right? So for this one, at the first step, we just changing to multiplication. So 2x, and also we will check whether we can cancel something. So we just fact at first. So 3x minus 12. So we can put the 3. We can take a 3 outside. So x minus 4, right? So here, division we can change to multiplication. Okay. So then here, numerator become denominator. So x squared minus 2x. So we can take x outside, just like x minus 2. And so x squared minus 6x plus 8. We can factor this as like this, right? X minus 2, x minus 4. X minus 2, x minus 4. Okay, so we can cancel many things, many terms. So we get, let's say, cancel this x. Cancel this x minus 2. Cancel this x minus 4. Almost canceled everything. Only this left. Okay. Okay. So for polynomial function, we have polynomial equation. So for rational function, we have a rational equation. So here, solve those equations. We say, well, first things is we don't like those denominate. We want to get rid of those denominates. So let's say, like, first one actually is the linear equation, right? We don't like this denominator, so we want to how can we get rid of those denominators? So we don't like this 2, so we just multiply 2, right? We don't like this 3, we just multiply 3. We don't like this 4, we just multiply 4. So we just multiply those denominators together. Then we can multiply this number, we can get rid of all those denominators. But here we say if we multiply 4, then we don't need to multiply 2 because 4 already included 2. So we just multiply 12. Okay? So multiply 12 to get rid of those denominators. So multiply 12. So first one becomes 6x, right? Multiply 12. And so here this multiply 12 just like 4 multiply this, right? So equal, so this become 3. Multiply 12, so 12 or 4 becomes 3. So this is a linear equation, or integer equation, or polynomial equation. So we put x together, so we say x, we have 6x plus 8 minus this 3 equal constant. So constants here, negative 4, we put 4 here, and plus 3. So this equal, let's say, 11x equals 7, right? So we can easily get to the solution. Okay. So for our second example, denominator we have x, we have 3, we have x. So we just multiply the 3x. Multiply 3x to get rid of all those denominators. So first one, multiply 3x, Just like that, like 2 over x multiply 3x. So cancel x just equal 6, right? Okay, so 5 over 3 multiply 3x, cancel 3 so equal 5x, equal, so 7 over x multiply 3x, so equal 21, right? So then this equation become very easy. 5x equal 21 minus 6, 15. Yeah, 15, right? So very easy, we can get the x. So for this equation, so denominator x plus 3 and 4, so we just multiply x plus 3 and 4. We just multiply this. So multiply this for left side. So cancel x plus 3, just like 4 times 7, right? So equal, so x over 4 multiply this like just like x over 4, this multiply 4 times x plus 3. So cancel 4 become like x times x plus 3. So this process we also can call this process as a cross product, like just the 7 times 4 equal x plus 3 multiply x, right? So this becomes a polynomial equation, right? So this is just like x squared plus 3x minus 28 equals 0. Okay, so how can we solve this? So we use factoring 1, 28 is 47. Yeah. Okay, so we know we can factor this way, right? So the solutions of this one is that is x minus 4 multiply x plus 7 equals 0. So we get the solutions of 4 and negative 7. So here the idea is quite the same. Just we don't like denominator, we don't like a fraction, we prefer integers. Okay, so here just like simplify. Simplification, simplify. This is the key point. Okay, so this equation, let's see, looks quite complicated. Okay, so we say if that denominates, we also can cancel those denominators, multiply 4x minus 1, multiply this, multiply all those denominators. But before we multiply all the denominators, we just check whether we can simplify. Because multiply this denominator is too huge. So we simplify first. First one, I think we cannot simplify. So for second term, so let's check this. 4x squared plus 11x minus 3. So simplify is just a fact. Whether we can fact. Okay, so here let's say 4 is 2, 2 or 1, 4. 3 is 1, 3 offset to make 11. So I think it's 1, 4. And so 3 is just 3, 1. Okay, so in this way we can make 11, right? So 11 positive. So here positive, so here negative. So this means we can factor this as x plus 3 and 4x minus 1. Okay, so for numerate, let's say, numerate ax squared plus 12x plus 14. So let's try factor this. So here 8 is 2, 4. Let's say, let me try 2, 4. So 14 is only can be factored as 2, 7, right? 2, 2, 7. Or 7, 2 or 2, 7. 2, 7 is this way, okay? The same is not okay. So 7, 2 not okay. So let's see whether this one. Let me try whether this one can be can be simplified. Ax squared plus 12 x plus 14. Hmm? Maybe this problem I may made a mistake. Maybe. Okay. So numerator maybe we cannot factor. Anyway, the denominator we can factor. Okay, so this means like this one can be the denominator is 4x minus 1, right? And so here we have denominator 4x minus 1. So here we have denominator 4x minus 1 and x plus 3. And here denominator x plus 3. Okay, so we know we just need to multiply this denominator. We just need to multiply 4x minus 1 times x plus 3. Okay, okay. So first term multiply this, so this becomes 13x plus 16 multiply so x plus 3, right? Plus second term cancel this. The second term just keep this the ax squared plus 12x plus 14. So equal. So this equal. So multiply. So here just cancel x plus 3 multiply 4x minus 1. Okay, so this is second degree polynomial equation. So we can so to solve this equation, at first we need to write this in standard form. So we just check x squared. The x squared term. Okay. Sorry. Sorry. Okay. So x squared term. So the coefficient of x squared is we can check x squared term. So we have a first one 13 plus a. So minus here 20 times 24 times 4. This x squared coefficient. Then for x1 coefficient, so x1 is here, so 2 times 3 plus 6 times 1, so plus 12, so minus here 24 times negative 1, so plus 24. And negative a multiply 4, so 2, right? Then plus constant. So constant is 16 multiply 3 plus 14. So and move this plus 8. Negative. Ah, no. Here's negative minus here. Negative 8 multiply negative 1 is positive 8. So move this positive 8 to left side is this. So we get this second degree polynomial equation, right? Okay. So I just left you to finish this. Okay, so fraction, we say so fractions, integer over integers, we have a fraction. Then we can have fraction over fraction. So we call those as a complex fraction. So complex fraction, at first we need to simplify. So like this, like okay, so this is we call this the complex fraction. So the idea is the same. We want to get rid of those denominators. So here we have denominator 3, we have denominator 4. So in order to get rid of them, so we just multiply 3 times 4, or just multiply 12. Okay, so we just multiply 12 to each one. So 1 multiplied 12 is 12. And 2 over 3 multiplied 12. 2 over 3 multiplied 12 is 8. Okay? And 2 times 12, 24. So minus, so 3 over 4, 3 over 4 multiply 12, or 3 over 4 multiply 3 times 4, just like that, like 3 over 4 times 3 times 4. So cancel 4 equal 9. So this equal like 20. So here, 24 minus 9 is 15 or 15. No, 9. Is this correct? 24, 15. Yeah, 15. Okay, so then this one certainly we can simplify furthermore, equal 4 over 3, right? Okay, so the idea is quite simple. We just multiply those denominators to get rid of all those denominators. So we call those denominators subdenominators. And so for this problem, same idea. We have denominator 4, right? We have denominator 4 and 2 and x, right? So we just multiply 4 and 2 and x. But again, like if we include 4, so we don't need multiply 2. So we just multiply 4x to each one. Okay. 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 So for first term, x over 4 multiply 4x, so equal x squared, right? So 2 over 3, oh, I'm sorry, 3 over 2 multiply 4x, cancel 4 to equal 6x. Okay? So 2 times 4x equal 8x. Okay. And 3 over x, 3 over x multiply 4x, so cancel x, so give me 12. Okay. So this one we find x plus we cannot cancel anymore, so just keep that. Okay. Okay. Now for this problems again we use the same idea. Like let's say here we have a denominator x, then we have a denominator 3, and we have a denominator 2x, right? So we just multiply them together. So if we multiply 2x, then we don't need to multiply x. Okay, so we just multiply 6x. We multiply 6x to each one. Okay, so multiply 6x, so 1 over x, multiply 6x is 6, and 4 multiplied 6x. Okay. Okay, so 5 over 3 multiply 6x equal 10x. Okay, right? And then 3 over 2x multiply 6x. Let's say 3 over 2x multiply 6x. Cancel, 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 cancel equal 9. Okay, so so this class, so here we just check those rational function or rational expressions. So for those things, we just we just simplify. If we can simplify, we just simplify. Okay, so simplify complex fraction or simplify by factoring. Those. Okay, so we can stop here. Okay.